1-5 practice problems, some of them together. And then it is your responsibility to finish them up on your own. Okay, so let's do the odds, and then you can do the evens on your own. Okay, so number 1 says, to describe the transformation necessary to transform the graph of f of x, the solid line, in this case they're blue, into that of g of x. So this is our good old parabola. So we'll call this f of x. That's x squared. And then g of x, we need to figure out how to make that equation do what we see there. So you'll notice that our vertex went 1, 2, 3 to the left. And we have learned that if we add on the inside of the function, it will move to the left. So we would need a plus 3 on the inside of the function. But this function has been flipped across the x-axis. So to do that, we need to put a negative in front. Now, how can you check your work? Well, go into Decimus, type in f of x equals x squared, type in g of x equals negative quantity of x plus 3 squared, and see, do you get the functions you see there? And you would, okay? Let's talk about number 3. It says, describe the transformation necessary to transform the graph of f of x into g of x. So work your way from the inside out, kind of like order of operations in a way. If you look, this negative 3 is going to flip it and stretch it. If it is on the outside, it flips it technically across the x-axis, so it flips it down. The stretch is going to be a stretch away from the x-axis, so it's going to be stretched, it will look higher, okay? And then this thing here is going to be a subtraction on the outside. Remember, subtraction on the outside moves it down 1 unit. So that's all you got to say, is that you flipped it, you stretched it, and you brought it down 1 unit. Okay? Okay. Now 5, we are actually given a set of instructions. We're going to write a function that does what they say. So it's expand it vertically. Vertically is a vertical line goes up and down by a factor of 3. So that's going to be a 3 on the outside of the function. If we're going downward, that is a subtraction on the outside of the function by 3. And again, check these in Decimus. Put in your original equation, put in your new equation. Does it do what you said it was going to do? Let's take a look at 7. We have the absolute value equation. We're going to expand it horizontally by a factor of 2. Now, anything that's done left to right always kind of does the opposite of what we would expect. So technically, you don't want to multiply by 2. We actually want to divide by 2, and then it'll expand it left to right, okay? Translating something up, you're just going to add 1 to the, oh, I'm sorry, that says to the right. Translating to the right, we are going to now need to go inside the function and add, subtract 1 would move it to the right, and then up would be 3 on the outside. So your final answer needs to have all of that. Again, how can you check your work? Well, go put it into Decimus. So will this expand it outward by a factor of 2? Will this move it to the right? Will this move it up? So there you go. Write g of x in terms of f of x. So initially, our f of x function for this one is our good old square root function. Now let's think what happened to it. Its vertex has moved to the left. So we definitely need an addition of 2 on the inside. It does need to flip over the x-axis. That's a negative on the outside. Let's look at 11. So we got that original function is our parent reciprocal function. And what has happened to it? Well, this is what I do. This is kind of our center. It has gone up 2 and left 1. And then this piece flipped up, and this piece flipped down. So we still need a flip. So our g of x function needs to move to the left 1 up 2. So left 1 up 2. So we would need an addition of 1 on the inside to move it left 1. An addition of 2 on the outside will move it up 2. And then we need a flip, so put a negative out in front. Okay. And then finally, 13, and then you're half done, is write an equation for that function and identify the parent function. So our parent function is the absolute value for this one, anytime it's a v. Our new function, okay, so let's see what happened. So you'll see there that it's moved to the right 2. So we need a minus 2 on the inside. And then you see how it's been squished down a little bit? So you see how, kind of think of slope of a line, if that helps. Up 1 over 3. So I think of it as having a slope of 1/3 or a height of 1/3. The fact that you can think of absolute value each side as like a little slope is very helpful. So its new height is now 1/3 of what the old height was, so it got kind of squished down. So then you have the rest of the period to finish this up. There you go.